Welcome to The Explainer. Today we're diving deep into the incredible cat-and-mouse game of web security. You know, that constant battle between the digital bouncers guarding our favorite websites and the clever hackers who figured out how to sneak right past them.
So in this explainer, we're going to break down exactly how these attackers find the blind spots in that critical first line of defense, the web application firewall.
All right, so before we can figure out how to get past the guard, we first need to understand, what it is and what it even does. In the world of web security, this digital guard is called a WAF. A WAF, which stands for Web Application Firewall, is a security system that basically stands between you and the website. Its whole purpose is to analyze all the incoming traffic and filter out anything that looks malicious, like, say, the code used in a cross-site scripting or XSS attack. The easiest way to think about it, it's literally a bouncer for the entire website. Its job is to check every single request trying to get in and make a split-second call. Are you a legit user, or are you a threat that needs to be tossed out right at the door?
Now here's where it gets interesting. This digital bouncer doesn't just have one way of doing its job. It usually operates from one of two completely different playbooks. The first playbook is called blacklisting. This means the bouncer has a big list of known troublemakers and just blocks anyone who matches those descriptions. The second is whitelisting, which is more like a super exclusive club with a strict guest list. If your name isn't on the list of known good people, you are not getting in. End of story.
Now, because most modern websites are just so dynamic and complex, trying to maintain a strict whitelist is almost impossible. So the vast majority of WAFs rely on blacklisting. But this creates a huge flaw. Attackers are constantly coming up with new disguises, and it's a never-ending game of catch-up to keep that blacklist updated with every single new threat.
So, if you're an attacker, you know this. Your first move isn't to just rush the door. No, it's to figure out exactly which bouncer you're dealing with and which playbook they're using. It all comes down to that classic military strategy. Before you even think about launching an attack, you have to gather intel. And in the world of cybersecurity, this whole reconnaissance phase has a name. It's called fingerprinting. Fingerprinting is pretty much what it sounds like. It's all about poking and prodding the bouncer to see how they react. Attackers will send these specially crafted requests, some harmless, some maybe a little bit malicious, just to see what clues the WAF leaves behind in its response. And these clues, well, they act just like a fingerprint, revealing its true identity. And you can see just how unique these fingerprints can be. For example, a WAF called mod security often gives itself away with a 406 not acceptable error. An F5 WAF, it adds a special cookie to the response that starts with the letters TS. Barracuda adds its own unique cookies, and Security will just straight up tell you you've been blocked. Every single response is a potential giveaway. Okay, so once an attacker knows the bouncer's identity and the rulebook they're probably using, the real game begins. Now they can start crafting attacks specifically designed to get around that WAF's known weaknesses. And this isn't just random guesswork. There's a real method to the madness. Attackers follow a very systematic process. They'll start simple, maybe testing if they can inject some harmless HTML. Then they escalate to trying different variations of script tags. And then they'll move on to testing specific attributes and event handlers, all while taking meticulous notes on what gets blocked and what slips right through. So their very first attempt might be the most famous XSS payload on the planet, a simple script tag. Any halfway decent WAF, or bouncer, is trained to spot this from a mile away and will shut that request down immediately. No surprise there, right? But what if the WAF is only looking for the exact lowercase string script? By just mixing up the case, an attacker can sometimes completely fool these simple pattern matching rules. See, the browser doesn't care about the case. It'll still run the script. But the bouncer, who's looking for a very specific pattern, gets tricked and lets it right on through. Now, when simple tricks like changing the case don't cut it, attackers move on to a much more powerful technique, encoding. You can think of it like passing a malicious note to the browser, but you've written it in a secret code that the bouncer has no idea how to read. Let's look at a fascinating real-world example of how a firewall for the Laravel web framework was bypassed. The attacker didn't just encode their payload once, they actually encoded it twice. So here's how it worked. The attacker sent a package with 2 layers of wrapping paper on it. The WAF, our bouncer, unwrapped it one time, looked inside, saw what looked like harmless packing material, and said, "Okay, this looks fine," and let it through. But once it was inside, the web browser unwrapped it that crucial second time, revealing the malicious script hidden inside. But the most elegant bypasses, the truly clever ones,
exploit a fundamental limitation of the bouncer. They use an attack that the bouncer is structurally incapable of even seeing.
This is known as DOM-based cross-site scripting, and it's a really sophisticated attack that targets the victim's browser directly. How? By exploiting a simple fact about how web addresses work. Certain parts of a URL never actually get sent to the website's server in the first place.
This is the WAF's ultimate blind spot. You've seen a hash symbol in a URL before, right? Well, anything in that web address that comes after the hash symbol is handled only by your browser. It's never sent to the server. And that means the WAF, which sits on the server, has zero visibility into it. It's like an invisible person just walking right past the bouncer.
So by crafting a URL like this one, an attacker can hide their malicious payload right inside that hash fragment. When a victim clicks the link, their own browser gets the full URL. And if the website's code is vulnerable, it'll take the content from that hash and execute it, triggering the attack. The bouncer never even knew it hit him.
And this really gets to the heart of why we still see these massive data breaches happening at huge companies with super expensive security systems. It's not a set it and forget it kind of problem. It is a continuous, strategic game where attackers are constantly evolving their methods to get around the very latest defenses.
And that leaves us with a really critical question to think about. If the main guard at the door can be studied, tricked, and even completely sidestepped, we have to realize that real security is a layered responsibility. Relying on just a single bouncer at the door is never, ever going to be enough.